Welcome and welcome back. My name is Natarajan, and today I'm going to demonstrate the Critical Path Method 101, also known as CPM 101. Now, I'm a sixth grader in a school called Paradise Canyon Elementary in La Cañada, California. These are the slides in my uncle's training in which he edited so I can make this video. Learning outcomes. First, we're going to learn to sequence activities. Next, we're going to learn more about the network diagram. Then, we're going to find out about the critical path method. After that, we're going to calculate the activity's start and finish date. Then, we're going to calculate not the root beer float, but the float or slack. And finally, we will identify the critical path. Sequencing activities. Now, let's say this is our network diagram here, and we have our activities and their relationships, and then we have our start milestone and our finish milestone, and then we can do this by hand, or we can let the computer do it. Now we're going to talk about the finish to start relationship. It's not like a human to human relationship, it's a finish to start relationship. So let's say we were painting the house. And let's say B here is actually painting the house. Before we actually paint the house, we need to prepare the surface. Let's say prepare the surface is A. Before we start B, we need to finish A. Now we're going to talk about our critical path method overview. Now, I'm going to read all these verbatim and then I'm going to talk more about it. Now, CPM is a network diagramming technique used to predict the total duration of the project. Basically what this means is CPM is a technique used to predict the duration of the project. Now, second, a critical path method for the project in a series of activities that determines the earliest time which the project can be completed. What this means is the critical path for the project is the earliest time the project can be completed. Now, third, the critical path is the longest path through the network diagram and has the least amount of slack or float, usually meaning 0. Basically what this means is the critical path is also the longest path through the network diagram and has 0 as the slack or float, or the least amount. Now, slack or float is the amount of time an activity can be delayed without delaying the succeeding activity or the project finish date. For example, let's say we were a project manager, and the start date of the activity can be delayed though, but as long as we don't delay the succeeding activity or the project finish date. Calculating the critical path. First, we need to have a network diagram, and it should be a good one. And after that, we need to add the duration for all the activities in the path through the network diagram. And then we will know that the longest path is the critical path. Determining the critical path, or the longest path. Here we have 3 paths: Path A, Path B, and Path C. Path A has 8 days. Path B has 14 days. And Path C has 13 days. So we know our critical path is Path B, since it has 14 days. Another way we could see it is Path B is on the red, and the red would basically be the critical path. Activities in a series. Basically what this means is we do one activity after the other. For example, let's say we're painting a house. First, we need to prepare the surface, then we need to paint the undercoat, and then we need to paint the top coat. Activities in parallel. So why would we want to do activities in parallel? Well, to shorten the project duration. Let's say we are painting the same house, and we have 2 painters, one painting the dining room and one painting the bedroom. So what we would do is first we would prepare the surface, and then after that we would paint the bedroom. At the same time we would paint the dining room, and after that we replace the furniture. activity list. So this is our project. We have a big house, and downstairs is bigger than the upstairs. So here we have our activity ID number, we have our description, we have our duration, and we have our predecessors. So here we have our project in Gantt chart form. We have our start and our finish, and then we have our activity numbers, but I will talk about this in a different video. So here we have our network diagram for the same project, and we have our key here, and we have our ID number here, and ID number here, and then we have our duration here for a key, and then here. And by the way, for the top path is our downstairs, and the bottom path is our upstairs. Now, I want you to guess which 500 is for our description. Now, if you guessed upstairs paint top coat, then you are correct. Now we're going to talk about forward pass. Forward pass calculates the earliest start and finish dates. Now, these are the rules for forward pass. The early start of the first task must equal day 1. Now, the early finish equals the early start plus the duration minus 1. Now, the early start of the next task equals the early finish of the previous task plus 1. Now, the early finish, this I'm going to talk about a little bit later. So now we're going to calculate the early start and finish dates. So as I said before, for the forward pass, it would equal day 1. So here we have our key, and we have our early start, which is here, and we have our early start, which is here, and we have our early finish here, and we have our early finish there. So now, in order to calculate our early finish, we need to do our early start, which is 1, plus our duration, which is 2, which equals 3, minus 1, which equals 2, which is our early finish. Let's see if we got that. 2 as our early finish. So now we know that 2 is our early finish. So now, can you guess when 200 and 400 are going to start? I'll give you a little time. 1, 2. Now, I'm guessing that the early start for 200 and 400 is going to be the next day, which is day 3. And let's see if I'm correct. Now we're going to go to cloud 2. And as you can see, I am correct. 200 starts on our early start as 3. Now we need to find out what our early finish for 200 is. So we are going to do 3, which is our early start, plus the duration, which is 3, which equals 6, minus 1, which equals 5, which is our early finish. Let's see if I'm correct. Yes, I am correct. Another way to do this is to do it the finger way. Now, I'm going to hold up our duration, which is 3, and we're going to do day 3, day 4, and day 5. So, for sure we know it's day 5. Now, again, so now, after day 5 will be day 6. So day 6 is our early start for 300. Now, we need to find our early finish for 300. So we're going to do 6, which is our early start, plus the duration, 3, which equals 9, minus 1, which equals 8, which is our early finish. Let's see if I'm correct. Yes, I'm correct. Now, we're going to move on. So now, we're going going to look at our upstairs. Here we have our early start, which is 3, again as it was for 200. And now again we need to find out our early finish. So we're going to do 3, our early start, plus 2, our duration, which equals 5, minus 1, which equals 4, which is our early finish. Now let's see if I'm correct. Yes, 4 is our early finish. Now, after day 4, we have our day 5. So day 5 is our early start. Now, we're going to do our early start, which is day 5, plus 2, which is our duration, which equals 7, minus 1, which equals 6, which is our early finish. Let's see if I'm correct. Yes. So now we have finished our downstairs and we have finished our upstairs. And our early finish for 500 is 6, and our early finish for 300 is 8. Now, can you guess when 600 can start? I'll give you a little time. 1, 2. If you guessed 9, then you are correct. So now we have our cloud 4, or 600. So we know our early start is 9. So now we need to find our early finish. So we're going to do our early start 9 plus the duration 2. 9 plus 2 is equal to 11. Then we do minus 1, which equals 10, which is our early finish. Let's see if we got there. Yes, 10. Another way we can do this is to do the finger trick. We have our duration 2, and we go 9, 10. So now we can see that our project ends on day 10. So we found our duration as 10 days. Now you're probably wondering, what is the backward pass? Well, the backward pass calculates the late start and the late finish date without delaying the project finish date. Now, let's read the definition. Backward pass calculates the latest start and finish dates for each activity without delaying the project. Now, to find out the late finish for our last activity, we're going to do our early finish for our last activity, and that is going to equal our late finish. Now, rules for backward pass. Our late start equals our late finish minus the duration plus 1. Now, just to make it clear, the backward pass is actually the opposite from the forward pass. Now we're going to do our backward pass. So here, if you remember, I said our early finish for the last activity would be our late finish. And if you don't remember the late finish, here's the key. Late finish, late start, and late start. Now, we're going to find out our late start. So we're going to do our late finish, and then we're going to minus that from the duration, which equals 8. Now, 8 plus 1 equals 9, which is our late start. Let's see, 9. So here we have our late start, which is 9. So can you guess what the late finish for 300 and 500 is? And if you guessed 8, then you are correct. So now here we have our 8 as our late finish. So we're going to find out our late start for 300. So we're going to do 8 minus our duration 3 plus 1, which equals 6 as our early start. Let's see. before day 6 is day 5. So day 5 is our late finish. Now we're going to find, again, the late start. So we're going to do 5 and then have our duration minus, which is 3, which equals 2, plus 1, which equals 3, which is our late start. Let's see. 3 here. Another way to do this is to hold out our duration and go day 5, day 4, and day 3. And again, we have our late finish as 8, and we're going to find out our late start. So we're going to do 8 minus the duration, which is 2, which equals 6, plus 1, which equals 7, which is our late start. Let's see here. Now we're going to find out our late finish for 400, which before day 7 is day 6. So our late finish is day 6. Now we're going to do our day 6 minus the duration, which is 2, which equals 4, plus 1, which equals 5, which is our late start. Let's see. 5, which is our late start. Now, can you guess when 100 will have its late finish? If you guess 2, then you are correct. So now we know for 100, our late finish is 2. So we're going to do our late finish, 2, minus the duration, which is 2, which equals 0, plus 1, which equals 1, which is our late start. Now let's see if we have 1. Yes, we have 1. Now, after this, we're going to find out the float. So now, we are done with calculating our early dates and our late dates. But here, for the downstairs, our early dates and the late dates are the same. If you can see here, they're the same. But for our upstairs, our early dates and the late dates are different. See 5 and a 7, and we have a 6 and an 8. We're going to talk about this more in the next slide. Float or slack. Now, if you remember I talked about the float or slack, we could delay some activities as long as you do not delay the planned project finish date. Now, let's read the definition. Total slack or float is the amount of time an activity can be delayed from its early start without delaying the planned project finish date. Now, how do we calculate the float or slack? We know what float or slack is, but how do we calculate it? Well, we could do this 2 ways. The first way is we could find the difference between the late finish and the early finish, or we could find the difference between the late start and the early start. Now, I like doing it with the late start, the difference between the late start and the early start, which equals the float. So now we're going to do our late start, which is 7, and our early start, which is 5. And the difference between those is 2. Now, I'm going to do with our late start, which is 5, and our early start, which is 3. And the difference is 2. Now, I'm going to do it. So now, our late start as 1, and our early start as 1. And the difference is 0. And now, we have our late start as 3, and our early start as 3. And the difference is 0. And now we have our late start as 6 and our early start as 6. And the difference is 0. And finally, we have our late start as 9 and our early start as 9. And the difference is 0. We have our 0 float for 100, 200, 300, and 600, which means 100, 200, 300, and 600. And the path, another way to say it, the path for downstairs, is the critical path. And 400 and 500 have a 2-day float, which means they could dance around for a little bit. So here is our critical path, shown by the red line. We have our early dates, our late dates, and our float. We're almost finished, but now we're going to have our summary. Summary. So we have learned about the network diagram. We found out more about the critical path method. We calculated the activity's start and finish date. We found the activity float, not root beer float, but float or slack. And finally, we identified the critical path. Now, I hope you enjoyed my presentation. Today is February the 16th. Have you seen this movie? I've seen it, and I'm going to try to convince my uncle so I can see it again for doing this presentation. If you like this video, please leave some comments below, and it would really help. Thank you very much.